Okay, so this unit is on naming compounds and writing formulas, so I just call it the language of chemistry. Before we get into that, there are a few things that I want to clarify and make sure that you understand the phrases that I'm using. For instance, um, an abbreviation for a chemical name is a chemical symbol. So, chemical symbol means an abbreviation for a chemical name. You have to have one capital letter. Any letters after that must be lowercase. So far, anyway, all chemical symbols have two letters, 1 to 2 letters, three if it's a temporary name. And they'll have those until they are given their permanent name. So that's a chemical symbol. That's an element. If it's something for a compound like H2O for water or NaCl for salt, those are compounds. So we call those chemical formulas because they represent more than one atom. So a chemical symbol represents one single atom or one single element. A chemical formula represents a compound, and so the compound would have more than one element in it, more than one atom in it, so in other words, a molecule. So since it has more than one element in it, it's going to have more than one capital letter in it. So NaCl, the N is capital, the A is lowercase because that's sodium, C is capital, L is lowercase because that's chlorine. So if you remember that the second letter is lowercase, you'll know it's not Ci. Okay, so chemical symbol is if you have one atom of one element. A chemical formula is when you have more than one atom bonded together. So usually a compound. It could be a diatomic element, but otherwise it's a compound. So the sheet of stuff that we memorized had what said ion notation on it. That's basically just the symbol with the charge attached to it. So an ion notation is a symbol and the charge that goes with it. And the charge is written as a superscript, so it goes up above, like an exponent. And then at the bottom of that sheet that we memorized, it had what we called the polyatomic ions, which I had said before, they're kind of like compounds with a charge. Compounds don't have charges. A polyatomic ion is a group of atoms bonded together with a charge, which means that they can also bond to other things. So the charge goes for the whole group together, like phosphate PO4, -3. The -3 stands for the whole thing, the phosphorus with all four oxygens together. So to have a polyatomic ion, you have to have more than one element and you have to have a charge. Then what happens is these polyatomic ions bond to something else, and that makes a compound a polyatomic compound, which we'll talk about in a few minutes. Remember that atoms are neutral and ions are charged. Basically, they're just an atom that's lost or gained electrons. So, if somebody refers to an atom, then you assume it's neutral, same number of protons as neutrons. If they say something about an ion, that means it will have a charge, which means it will have a different number of protons than electrons. And remember that the the number of protons cannot change. So whether it's positive or negative, it got that way by either losing or gaining electrons, not protons. Protons are always the same. So just to differentiate between a positive and a negative, there's a specific word that means it's an ion that's positive, and a specific word that means an ion that is negative. The word for positive is cation. Cations are positive, and that's easy for me because I love my cats. So cats give me a positive feeling. A positive feeling. Ha ha. Okay, so anyway, anions, a negative ion, anion. So that's how I remember that one. Although usually if I remember cations, then I know what the other one is. There's different kinds of compounds, and so they are differentiated and named differently. So we're going to have 3 different ways that we have to learn to name a compound, 3 different ways we have to learn to write the formula. So to do that, we need to understand the difference in the different kinds of compounds. Now, if a compound only contains 2 elements instead of 3 or 4 or 5, then it is called a binary compound, because that binary means 2, so it has 2 elements. You'll know it's binary because it'll only have 2 capital letters. 2 capital letters in a compound's formula means it's binary. If you're looking at the name of the compound instead of the formula, you'll know it's binary by the ending of the second word. We always change the ending of that to IDE, ide. So sodium chloride instead of sodium chlorine. So if it ends in IDE, most of the time it is binary. There are exceptions to that, but most of the time that tells you it's binary. I'll let you write this, then I'll explain it. figured I might as well read a book while I was waiting for you to write that down. Okay, so poly means many, so polyatomic means many atoms. So it means that it has more than one atom of more than one element. So if it's a polyatomic compound, then it's going to have more than two elements in it. So you'll know it if I give you the name of it, like sodium sulfate. You'll know it because the ending of the second word, it's usually ate or ite the majority of the time. But again, there are exceptions. But if you see ate or ite, it guarantees that one definitely is polyatomic. If you're looking at the formula, that's easy too because you just count the capital letters. If it has more than two, you know it's poly. An ionic compound is formed from ions, charged particles. So a polyatomic is an ionic. It's both things. It's polyatomic and it's ionic. And then you can have things that are also ionic that are not polyatomic, like sodium chloride. So if it has, see, how can I say this? If it has charges, if that's how you find it is with charges, then it's ionic. If it has a metal and a nonmetal, that's ionic. Covalent doesn't have any metals in it. I'll let you write. Since a covalent bond involves the sharing of electrons, there are no charges. In an ionic bond, an electron actually moves from one atom to another, so that leaves both of them as being charged. In covalent, that doesn't happen. They share their electrons. So there's no ions, there's no charges. They're made only of nonmetals. In other words, metals won't share. And if you're looking at their name, you can also tell because there will be prefixes on the name, such as mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and it goes on. But usually you don't need that many. Okay, now we do the three types of compounds. They're kind of determined by those words, the vocab words I just gave you. For instance, if it has two elements in it, it's called binary. If it has more than two, it's called poly. Also, like, do they share electrons or do electrons actually come off of one and go on to another? That would be the difference between covalent and ionic. So let's take a look at the three different types. Now remember, I had told you a while back that there was going to be a lot of memorizing to this chapter. The key to doing well on this test, and this, by the way, is the number 3 of the 3 most important lessons that you can learn in first semester to help you throughout the rest of the year. 1 was factor label, 2 was significant digits, and 3 is naming and formula writing. If you can get those 3, they will help you immensely throughout the whole rest of the year. So I would say start reading through your notes. If you want to make yourself flashcards, anything to start memorizing now to get through the whole chapter. Everything that was on that memory sheet you should have memorized by this test. Plus, there are going to be rules for naming each kind of compound and rules for writing formulas for each kind of compound. So there's quite a bit of info here that you need to know. So let's get started. Okay, first we have the binary ionic compounds. These have exactly 2 elements in them, no more, no less, and one of those elements has to be a metal and one a nonmetal. There's no other option. So if it has 2 capital letters in the formula or it ends in "ide" in the name, it's probably binary, and then you have to look and see, is there a metal and is there a nonmetal? So you would have to look the elements up on the periodic table. On the left of the zigzag line are the metals, and on the right are the nonmetals. The metal will always come first. You always have to list the most metallic element first. And I will have you going either from the name to the formula or the formula to the name, and that rule applies to both. So if you keep them in the order I have them in, they'll be in the right order. Okay, so if it's binary ionic and you're looking at the name of it, it will end in "ide", and nothing will have a prefix on it. So no mono, di, tri, tetra, etc. So it ends in "ide", but there's no prefixes on either word. If you're looking at the formula, it has 2 capital letters, and the first element's a metal. Like I said, the most metallic element has to be listed first, so if there is going to be a metal, it'll be the first one. Okay, the second type is binary covalent. Still only 2 elements. But this one won't have any metals, which means both of the elements will be nonmetals. So there's the kind of compound made out of a metal and a nonmetal, the kind of compound made out of just nonmetals, and the ones made out of just nonmetals, because it's binary, the name will end in "ide", but at least one, if not both, of the words will have a prefix on it, like carbon dioxide. That's a binary covalent. Oh shoot, I keep forgetting this mouse is not left-handed. So it ends in "ide", the second word ends in "ide", and it has at least one prefix. Now sometimes it'll have 2, like dinitrogen pentaoxide, where both words have a prefix. The reason for that is that if the prefix on the first word is mono, they drop it. So you can't drop mono on the second word. You can't drop the prefix on the second word no matter what. So look at the second word to see if it has a prefix, because sometimes it's been dropped off that first word if it's mono. Looking at the formula, it'll have 2 capital letters, and then once you know it's binary because it has 2 capital letters, check to see if the first element's a metal. If it's not, then you're dealing binary covalent. So the binary covalents, remember they share electrons, whereas binary ionic, the electron comes off the metal and goes onto the nonmetal. So because of that, we have to name them differently to show that that's what's happening. I didn't make the rules. I just know what they are. Okay, the last kind is polyatomic ionic. So it's also ionic, it forms with charges, but it's got more than 2 elements in it. So it's got at least 3, in other words. Sometimes 4, rarely 5, but sometimes. These are probably the easiest to tell by name or formula. If you're looking at the name, they'll end, the majority of them, there is 1 or 2 that end in "ide," which really messes things up. But other than that, like hydroxide that you memorized, but other than that, they pretty much end in "ate" or "ite." Excuse me. So I just go down through. If I have a list of compounds that I have to name or write formulas for, I go down through and I find all the ones that end in "ate" or "ite, and I mark those as polys and do those first. That only leaves you with binary ionic or binary covalent, and you just got to figure those 2 out. And if you're looking at the formula, it's even easier because there will be, since it has 3 or more elements, there will be 3 or more capital letters. So if there's more than 2 capital letters, you know it's guaranteed to be a polyatomic ionic. So those are the 3 types of compounds. We're going to go through how to write the formulas from them, from the name, and then we'll go through and learn how to take the formula and write the name. Basically, the rules, I said basically again, sorry. The rules have one overall rule, which is write down as little as possible to communicate still all of the information you need. So if you can get across what the person reading it needs to know, without using prefixes or without changing the ending or without whatever, then that's what you do. So you want to write down as little information as possible, but still make it usable to the reader. So that's where we go next.